Thank you. It's really hard for me to stand in front of a microphone and not move around. Can you all hear me? Is that all right? Yeah. Right, so start waving if I start mumbling and you can't hear me. But I have more fun like this. So this is a quick summary of where things are, sort of menu of what's going on. So I'm not going to spend very long on any one thing. Please make comments, ask questions as we go along. We've got 30 minutes, right? I want to say a little bit about participation as well. So, here we are. State of play today. So GHC 8 is out. What's in it? I was out a few months ago. So, George, one of the things you'll notice that pretty much every single thing has a name attached to it. So all of these things are done by people other than me. And that's a recurring theme. You will see this was true last year as well. So George did this thing on making pattern match warnings GADT aware. And to be honest, I think that the implementation, the paper is very beautiful, and the implementation doesn't quite match its beauty. So I think it could be, there's more to be done there. There's a reason for it. George found performance, you know, he did the obvious thing and it didn't perform very well or something. So I feel as if that's not quite finished somehow. But George seems to be doing other things. So the other thing I'm just advertising is things that, you know, are virgin territory. So I think there's a little bit more work to do that. We did a bit on injective type families, also not concluded. So this is to improve type inference. When you've got, you're trying to unify f of a with f of b. Do you know that a is equal to b? Well, if it's injective, you do. But there's a bit more that to try to get all the glory of functional dependencies about how saying, well, if you know the first and the result, then you know the second. And that's partly implemented on there's a branch that's incomplete. So anybody wants to finish that off, be my guest. You heard about applicative do notation from Simon's talk yesterday. Lovely stuff on implicit parameter support for call stacks. Who's actually using this? Is it Eric Siegel's work? This is really helpful for trying to, if you call error, rather than just saying you called error, you can get yourself rather incrementally and non-invasively, you can get yourself a bit of a call stack. And it's, I really like it. Johan Tibel is not here this year at all, is he? But he provoked all this strict Haskell stuff, so if you switch strict on, you get pretty much call by value semantics, but it's carefully arranged so that you don't have to do that for your entire program. And Adam did quite a lot of work on, there's a grand overloaded record fields proposal, which is split into two pieces. I said this last year in more detail, you may remember. So the duplicate record fields part is kind of done, and he's got a proposal, actually in the GHC proposals process we'll hear more about the overloaded record field part. Then here's something that you may not have crossed your radar quite so much. Undecidable superclasses, also known as recursive superclasses. This is exclusively to satisfy Ed Kmet, who said, you know, Simon, he said, this ought to be fine. Look at it. Here's integral domain. This is a class declaration with itself as a superclass with a bigger type. I mean, this looks really crazy, right? But actually, if you work it out, you know, that it's got a superclass that's integral to grain of frac of A, and therefore it has a superclass that's integral to grain of frac of A. But he also says that frac of A is equal to frac of A, so at this point we reach a fixed point, and so there are only a finite number of superclasses, even though it looks as if there's going to be an infinite tower, so everything's fine. And it turns out that it's actually quite useful, and so provided it does have a fixed point, everything terminates nicely, the type checker will do this really quite well, do a good solid job of it. I'm quite proud of myself. But if you do write an infinite tower, then the type checker will go off into la-la land. So that's, as usual, undecidable means you on your own. Yarvor did this very nice thing on user-defined type errors. Who's used this? Just, you know, okay, so everyone else, you may want to use it. So here's the payoff. You put the details in the user manual, but here's an example. If you want to say, you really shouldn't be using show of A arrow B, right? If it ever uses this instance, it'll get this strange type class type error, and then when rendering error messages, rather than saying, I can't find an instance of type error, it renders the error message different to print out this little text. Cannot show functions. Perhaps there's a missing argument. Don't you think that's rather cool? So I'm sure there's more juice to be had there. Yarvor, are you still actively thinking? Are you still actively thinking about this, or do you think this is done? Do you think this is enough?
Oh, I don't think it's enough, but I'm also not actively thinking about it.
Right. So more. So I think this is a good start, but probably not finished. Was it Leonard who originally suggested this in the first place?
Yeah.
Yeah. Like many things. Let's see, pattern synonyms. This was a version of this was in GHC 710, but it's much, much solider. in GHC 8, and all the stuff about types that Gergo's lovely talk on the other day told us about is solidly implemented, along with record syntax. You can declare a pattern with record fields and then match on it as if it was a record-defined pattern. So that's very nice. And also, I'm a little less certain about this. I don't know what you think. This is if you're here's a data type T with two constructors A and B, and a pattern synonym which is does something involving, but it produces a T, right? So it's a pattern that matches things of type T. So from outside, you might think it behaves rather like a constructor of the data type T. So you might like to export it as part of, T export the constructor A, the constructor B, and the pattern P. And then when you import, you might like to be able to say T dot dot. So from the customer's point of view, he's not really making this very strong distinction between. But there's something a bit weird about this, isn't there? And there's exactly when can you list something in here? And might be. So there's a collection of slightly arbitrary design choices there that are just described in the manual, and I'm not completely sure they're exactly right. But I'd be interested in experience about using this. Does it do what you want? And if not, what? And this is just to do with import and export. It doesn't really affect their behavior at all. Okay. Let's see. Visible type application. Yes. Professor Eisenberg, or assistant professor, associate assistant? Assistant, yes, well, I'll just call you professor. Yeah. So, who's heard of visible type application even? Almost everybody, that's good. So, yes, a polymorphic function. Usually the type arguments are inferred, but this way you can write them explicitly. And you can write any prefix of them. You can write 0, 1, 2, as many as necessary. You can't just write the second and not the first. Except, of course, with sort of underscores in types. Can you write @ underscore?
Absolutely.
Yes, I should have put that. You can write map of @ underscore @ bool. And then it will say, that underscore is int. It will tell you what it is. So it sort of fits nicely with the type wildcards game. I really like this because it means that there are quite a lot of there are applications where you have class methods where there's a sort of proxy argument that was really just playing the role of a type thing, and now we can just do it, do it right. Yeah.
If you leave the underscore, can you just still compile with the underscore?
Oh, you can still compile with the underscore. It just reports it. Yes. It doesn't prevent it. I'm not sure whether you can completely suppress the warning.
No, it doesn't record it.
It doesn't record it at all.
It's a special case because most of the time you just want a placeholder, so it just consumes it without leaving.
Oh, but you can get it to tell you, can you?
Actually, I don't think you can.
Oh. Because I think you might like to say, I don't know what the type is, tell me, and then you can put it in.
Yeah.
Okay. I think it's very good. So this is sort of incrementally training people to think about what are my functions abstracted over and what types am I applying them to. Also in GHC, the various things in the runtime system. So this is Simon Marlowe. So Simon Marlowe will answer all questions about this. Various scheduler improvements. What is this? Use fewer garbage collector threads than mutator threads. Why would you want to do that, Simon?
So you can have more mutator threads than cores, basically.
More mutator threads than cores?
Yeah.
Oh. Right. Anyway, it's good. But this, I understood this line, right? This sounds really pretty good, doesn't it? Actually, 15% performance is a big number on the way things are today. And why are we dividing, having different size nursery chunks, Simon?
Well, when you're running in parallel, you have the same size nursery on all of your cores. Some cores will allocate faster than others, so you lose some memory if you reduce it as soon as one of them is finished. So if they all share memory, you divide it into chunks and share each of the cores.
Oh, they steal each other's nurseries?
Right.
Ah,
Well,
it's
they
like,
steal from a common core.
like stealing their toys. You're not using your toys. Right, cool. Alright, so that's runtime system stuff. So I left this till the end. This is why it's GHC 8.0 and not 7.12. Right, so this innocuous little thing of saying star has kind star occupied Richard for the last 2 years. Three. So in a way, it's superficially not much has changed, but a great deal has changed in the internals. A great deal has changed. So now types and kinds really are the same thing. And when you declare data types, previously you can give them type arguments, and they had some implicit kind arguments if they were polykinded. Now you optionally can give them explicit kind arguments too. So types and kinds really have become completely collapsed. And that's great simplification in some ways, but there's an awful lot of paddling under the water that goes on to keep the thing straight. One thing that you will come across sooner rather than later probably is that it becomes less and less convenient to use star to mean the kind of type, so that it's also spelled type, but you have to import this, don't you?
Yes.
Yeah. From ghc.types or something?
Data.kind.
From data.kind, right? Right. So it's now spelled type, and it may be increasingly, you may have to do this in some circumstances in the future. Is that more or less right? So what does this mean? The fact that you could promote simple vanilla algebraic data types, we've been able to do that for some time. But now you can promote GADTs. And so I'm scratching my head and thinking, why would I want to do this? But so I've been spent years trying to say, why would really, Richard and Stephanie, why do we want to do this? And finally, it was the thing that really persuaded me was when we did type rep. So there's a paper called A Reflection on Types, which is from Waddlerfest. It's on my homepage and Richard's. And it gives a very nice example that shows why binding kind equalities in GADs, but when you do a pattern match in a GADT, we're used to them bringing type equalities into scope. So in the branch of a case, you know that A equals int. But in a branch of a case, you might now know that K1 equals K2 arrow star, right? Where there's a kind. That's super important for certain applications. You just can't get away without it. And so I was finally dragged kicking and screaming into a little bit closer to the world of Propinacta. Let's see, I was wondering about the sort of articulate exposition of the kind of things you can do with GHC8, but not the full glory of what's in your thesis. And we don't really have a good tutorial on that yet, do we?
No, we don't. Although there'll be an example later today.
Right, so we're going to, yes. So Richard will give you some examples later today, but I think it would be quite helpful if people here maybe even wrote blog posts and examples to say, what can you do with this stuff? Right? That would be really quite useful, because at the moment it's kind of like an amazing engine whose power we don't quite know yet. All right, but that's why it's GHC 8.0. Okay, that's enough for 8.0. 8.2, what's happening? So our plan for 8.2 is that it's really supposed to be a consolidation release. Like 8.0 has all this new machinery, and needless to say, it has plenty of things wrong with it. And so the idea for 8.2 mainly is to consolidate, right? To try to make everything in 8.0 work smoothly and well and solidly and so forth. And also to improve the performance of the compiler, because it's a long time since we've really focused attention on performance. So hopefully during this year, particularly if some of you help, right, we'll actually make the compiler run faster. Because what tends to happen over time is we add more and more stuff and it gets slower and slower. And then everybody hates that, including me. So that's our intent. There are some small things that are small but important things that are happening. Ryan is working on improvements to deriving. Where are you, Ryan? You here? Yes, right. So Mr. Deriving over here. If I had £1 for every email I've had about deriving clauses, which initially was a very small feature of Haskell, you know, let's just have a way to say deriving eq, right? We're kind of like a 10-minute conversation at the Haskell committee. But deriving has turned out to be a whole big little world of its own. Anyway, Ryan's in charge of it. Thank you for doing that. Omer. At Indiana, Ryan Newton's colleague has been working on unboxed sums, and I think that has further to go yet. Simon is working on some concurrency stuff. Is it Simon and I guess and Ryan at Indiana? Are those the main protagonists here?
No, it's not.
I know, but I know Ryan's gone. I'm looking at Simon to say who are the main protagonists for this sort of thing. It's
well, the compact region stuff originally came from.
Well, that was with Ryan and Edward, yes. But you're keen on compact regions,
yeah, so I've been working on merged division platform.
Speak loudly, because there are people on the other end of the working work here.
Yeah, I'm working on improving some aspects of that. And the NUMA stuff comes from work I've been doing on Facebook.
Is this another 15%, by the way?
Yeah.
Yay! 15% compound on an annual basis would really be I could invest my money at 15% compound interest, I think. So, yeah, just get me, have Simon Marlowe on the team, yes. You heard the talk about Hadrian yesterday. And here, again, there's what, so Hadrian is now capable of building GHC, but there's a lot of other stuff, you know, there's cross-compilation support and building all packages and so forth, so there's quite a lot of filling out to do that we really need help with. But it'd be really nice to switch from the old make system to the new Hadrian system. It's really quite hard to maintain two large build systems in parallel, so help needed there. Bartos, who's not here, as he knows, hello Bartos. Bartos has done an amazing job on making compilation deterministic. So if you give it the same input, you get the same output, which you might think was an obvious enough thing. But GHC allocates these unique names in compilation, and very small differences in the input could make the outputs change, more or less. Is that right?
Yes, and it actually comes with 802. Like it should be visibly deterministic.
Oh, right. So even 80 is. I should have.
802. Like if it gets
802. That's right. So the patch release that will come out will be. So there's a lot of very painstaking work here, right? It's not one change to make. You have to make changes in a lot of places. And Bartos has been very systematic and thorough about it. You have a chart on your wall that has sort of like 1 million nodes and dependencies between them, don't you?
Yeah, it's on my talk. Come to my
oh, okay, right. Yes, sorry. I've forgotten you. Right. And finally, so I said GHC 8.2 consolidation release. I don't think you could count Backpack as a consolidation feature. So it's likely to have one major feature. So we may finally get to the glorious future of that, which has been, you know, in the offing for many years. Are you going to talk about that today?
Yeah.
Yeah. Okay. Right. So I'll tell you what's that. Okay. So that's it for sort of what's ongoing at the moment for Boat 2. So I just want to spend a couple of minutes before switching to Ben to talk about you know, contributing to GHC, just to reiterate some things that most of you will know about the way that we work together. So here it is. GHC is really a big project, and a lot of people contribute to it. And so more and more, it is. You know, I wrote exactly these words last year, right? That it's really a community project. And so that the leadership of GHC is moving increasingly, you know, away from GHC HQ in Cambridge and towards all of you guys. So I want you to feel sort of, you know, empowered to propose and do things. Here are when I say the core team, this is people who actually, you know, have a kind of some, at least if not their day jobs. It's kind of my day job. It's not really Simon's day job, but we spend some real cycles on it. There's a lot of other people helped by way of volunteers. So I counted, I think 40 people have commission, but a lot more contribute patches. And this is very different to the way it was a few years ago. But I think of this crew as doing a lot of enabling rather than doing. So if you feel you're not being enabled, like empowered, and you're stuck, then you should make a noise. You're kind of the important ones. If all we do is make sure that everyone else is productive, we'll be doing a good job, I think. But for me, the background text is that, you know, where GHC's got the avoid success at all costs has not worked. And as a result, you know, that GHC has this very big surface area, and I've just sort of listed here stuff that is, you know, to do, and any one of these things repays, you know, the full-time attention of some, or sustained attention from a person, right? And there are a lot of these things, and I'm sure this is only a partial list. So when people say, could I help with GHC, they offer me, you know, I'd like to implement a new type system feature, right? Sort of that's right there in the middle. But there's this enormous periphery, which is actually easier to, more approachable to make changes to. And that's even if you're thinking about GHC alone, right? Then there's the rest of the ecosystem, and there's quite a lot of that. So, and unlike Swift and Go and you know, F# and Java, Haskell lacks a corporate sponsor, so it's in this kind of unusual space, which is doing quite well through our collective efforts. But we can't take that for granted, right? So we just have to. One of the things I hope we may do today is talk a bit about how people can get involved. And one thing, you're going to talk a bit about the proposals process, Ben? Well, yeah. Yes, you are. Okay. So one of the sticking points was, you know, how do decisions get made for how things get into the compiler? So Ben's going to be talking about that. So I just wanted to list here the things that I know that are sort of currently in flight. So this is the distinction is for the 8.2 list I gave is things we're actively thinking of that will be in 8.2. Right. This is more a list of things that I know of that are generally ongoing, and there are quite a few of them. The slides will be available sort of somewhere, probably. Yeah, so you can get hold of this and this. Right, I didn't mention anything about static pointers, but the guys at Tweak, Matthias Blofeld and Facundo Dominguez, busy, churning away, doing Cloud Haskell-y things and making incremental improvements to the static pointer implementation. So quite a lot of things that are on the go. Let's see. Yes. This is. I'm excited about this. So Luke already has a patch nearly ready to go for core with join points, which is just totally amazing. Ask him about it. It was a talk at the Hope workshop. So our ICFP paper was all completely wrong-headed. We found a much better way to do it. So one of the things we've done in previous years is just to stop at this point and say, okay, so that's a sort of menu of, at least from my point of view, what I see as ongoing. But what about, from your point of view, what would you like to see done? And then there's sort of to dual it, and maybe somebody else here would like to help do it. Where are the blind spots? What are the, what else needs to happen other than what I've described here to make GHC a compiler that you want to actually use? I'm going to sit here and type. Yeah.
I have a very small trivial one which I hope to be able to do, which is Joachim Breitner has GHC heap view.
GHC what?
GHC heap view. It's an external library that walks the heap and allows you to do things like count the size, count the number of bytes consumed by an object in the heap. It's fragile because it's outside of GHC. I've already spoken to Joachim. He thinks it's a good idea to move it into GHC.
Is he here? Yeah, he is.
He committed 10 minutes ago.
Oh, you mean it is part of GHC now?
I committed something else, but I'll do something from this room.
And it says so in the commit message.
Does anybody else use it?
Occasionally.
No?
It breaks really horribly sometimes.
So do you want it to be, do you want to make it part of the code base? Are you up for that, or does somebody else want to do it?
I've put my hand up.
Oh, you're volunteering, right, okay. Right.
Yeah.
It's a great teaching tool. You get visualize the heap. And, those who don't know how Haskell heap is structured, really is offers insight.
Right, even if you know in principle how it's structured, actually seeing how this particular heap is some vast place of spaghetti. Yes, Yavol.
How about data kinds? So we kind of have data kinds that promote types to the one level up. But oftentimes I don't want the value case, I only want the kind one. And I've had a go at doing that once before and we didn't quite finish it, but I think that will be quite a cool thing to do. What Leonard had in his talk.
So if you just say data T is T of type, isn't that a data kind? You can't use that in the world of values, am I right? Or am I talking nonsense?
You're right.
Yeah.
Well, but the one that Leonard was explaining about is also open. It's an open data kind.
No, that's the kind of thing I want, but yeah.
So this would be not usable at the type level, but you could still,
This is with the new...
It still is a type, but you just couldn't write down any values of it. But you want to write down one that...
Maybe we already have it, but with the previous one you had to put all the ticks and whatnot whenever things are promoted.
So I think this is just a namespace issue, right? I mean, you don't...
Maybe it's easy,
What
let's
you could do is you could say that. You can say that in GHC, which Simon's written. And then you can say type mct equals tick mct. And then that creates a new binding at the type level.
Yeah.
It's not, no, I see what you're saying. We can talk about it. I actually prefer not to do this. I think that this would make the namespace issue harder, not easier. But we can talk about it.
Should we put and attach your name to ER when you want to develop it? Or anybody else who's enthusiastic, yes.
So one problem we have in our code base is with performance, and we have all these great tools for analyzing, profiling. We have the heap analyzer, all this stuff. But actually, it turns out that our performance issues are due to specialization, and that's we feel like.
You mean the absence thereof?
The absence of specialization, which we feel is a black box. You can like look at some very complicated core output. There's like a fragment of output, all the specializations, but that's not very helpful to us. So we'd like to see a lot more, maybe some tools to help us see what's being specialized, why, and maybe why not.
In GHC8, at least now, rule there is warnings or fragile rules.
Yes, and those have been around for a while, but we're not getting any warnings about it. So that doesn't help.
Is this so? If you write a specialized pragma,
no, that doesn't always work. Neither does inline or inlineable. Those are very. I'll talk a little more about it in my lightning talk later, but
okay.
Yeah.
Okay, so need a bit more detail there. So
yeah.
Remind me of your name.
Eric, E-R-I-C, Crockett.
Two T's?
That's right.
Good. We should talk more later. Yeah, where we go? Right at the corner. Yeah.
Very, very trivially, I would just like to count errors. How many errors? How many compilation errors? It says I have a certain checklist of how many things I have to do. And I think that might be something that I could do.
Yeah. Cool. You're on. That would indeed be something that would probably not take long. What's your name?
Rob Rix. R-O-B-R-I-X.
Like that?
R-I-X.
R-I-X. Wow.
No, just R-I-X.
Oh, I see. No O-V.
Yeah.
Cool. Right. So this is for your sort of metrics for the beginning of the day. I had 800. Now I'm down to only 7. Well, yeah.
Yeah, can we improve a little bit tablet Haskell? And because the tablet Haskell, the grammar of Haskell, changes a lot, and some libraries are not compatible. And sometimes I want to, get a better interaction with GHC, like get if you have a data declaration, and I want to get the kind. The kind of the data type, or some other. You have a function declaration. I want to get the type signature inferred by GHC. Now we have to use extra library to do it, and now most of the libraries are broken because the syntax of GHC and the library something Haskell fix.
Is it stability that's the problem, or is it capabilities? Or both? Both, okay. There's change coming here potentially with the native business, as soon as that native kind of comes through.
Oh yes, maybe that'll be slow coming. If there are specific facilities that are missing that you need, then it'd be good just to make feature requests for them, at least, so we know exactly what it is. But the thing is, if you just say better template Haskell, then of course everyone will agree. But it's hard to disagree with it being better. It needs to be a bit more specific, yeah.
So just on the template Haskell thing, there's a part of the template Haskell API that looks like it would allow you to get the sort of the content of the function, like the expression, and it says, and the API is even set up to allow you to do this, but it always returns nothing. So it says maybe expression, then it would be great to have that actually.
Yes,
that's true. That would be great. Just in response to Song there, I think those two questions you asked, I think you can do that already. You can get the kind of a data type and the type of a function, but maybe we should talk about.
Yeah, those two should be able to. Yeah, back here.
Speaking of template Haskell, one thing I was looking for, a feature of template Haskell that I was needing, and it didn't exist, is like use template Haskell to list. That will probably be very hard to do, but list all the functions in scope, like the declarations in scope or something like that, or the ones in a file. I could obviously use Haskell SRC for that, but it would be great if I could only use the Haskell certificates already.
No, that part should be too hard actually, just being able to say, tell me everything that's in scope. Yeah.
Yeah. Should probably be very hard. Or some subset of the ones that were declared in the module, something like that. That that would make sense to me.
So as far as template Haskell is concerned, Richard sort of stepped up to be the king of template Haskell, but you're also king of various other things. And template Haskell, because it's essentially a meta, it lets you look at what the compiler is doing. So potentially, there's potentially a lot you could do. So it's potentially a sort of big thing. So it's quite difficult to keep track of. I'm sure you would like it if you had a few hench people.
Yes.
Right.
Yes,
so if anybody would like to, as it were, form a more persistent team, rather than make suggestions, actually, join with Richard and form a sort of team of 3 to, think about the design and indeed then implementation of template Haskell. I think you'd find that really helpful.
Yes, I would. And template Haskell, I think, is a great way to learn about GHC. I sort of recommend that to anyone who wants to learn about the internals, because it's actually quite separable from the rest of GHC. So, this last suggestion, that's a great project if someone wants to tackle. That's I think very accessible.
Anybody interested in actually working with Richard on in a more sustained way? Wait, just come and talk to him afterwards. Yeah, great.
Related to this, when we learn from other people's code, if you have unknown variable, you don't know where that name is coming from. So we would like to track that where this particular unknown function to me is coming from.
In the REPL or in
the library.
Library. You want to be able to ask GHC, because I think you could actually, if you load the library into GCI, then you can ask it for a source code with
So using stack maybe that's the other thing, the stack is too heavy.
Who is too heavy?
Stack.
Stack.
Too much CPU, too much time. I know what he's doing.
So that's an ecosystem thing. That's not a GHC thing, right? So you have to tell Michael that. Jochen.
So understanding what GHC does with core is a very tedious thing, like looking at core-to-core output. I would love to see a mode where GHC dumps everything it does in the machine readable format, and then have a separate tool where you can click forward, backward, see the changes in the code, lined, color-coded, fancy stuff. That would be nice.
That would be really good, yes, because I spent a lot of time looking at core output, and it's, the putty printer was sort of whipped up in a stray Sunday afternoon. It's not very good. So
yeah, keep scrolling up and downloads to compare with different regions.
Yeah.
Still, but I want to see before and after, not on top of the other, but rather overlaid or color diff and then click forward, backward.
Michael.
On that, maybe pull in the printers that Permit uses for core. That makes it reading a lot easier.
Cool.
I remember now what I actually wanted. It's not exactly everything that's in scope, but things that are exported by module. That would be really helpful. And there's like a blank space on the page that Haskell already, I think, but it always returns nothing. That would be a good thing.
Things that are exported.
Yeah, the exported symbols of a module. That would be great if we would have that. That would make some things easier. There is a feature in Quick Check which would be easier to implement using that.
I see. Yeah, but so the exported things of the current module, or maybe of a specified module. Yeah. Michael?
Macro extensions.
I can spot the racket.
I've got a few publications that secretly are only for being able to do this kind of stuff. I've got a lot of plans on how to do it, but I don't necessarily have time to.
Right. Well, so the other things we talked about, like 1 unit of work, 2 units of work, 1 unit of work. That's like 100 units of work. That's different in kind. I mean, template Haskell is that kind of thing, isn't it? So I'm gonna put you down for this. New macro system. Better than Ski.
Well, Ski doesn't have proper grammar supporting its macro system, so yeah.
There you are. All right, the gauntlet has been cast down. I'm conscious that we're meant to have finished 5 minutes ago. Who's chairing this session?
Yeah, I'm sure.
You're in charge, right?
But
keep going. Yeah, this is good.
So, if we're talking about pretty stuff, pretty error messages with colors and alignment and underscores.
This is wait, say that again and more loudly.
Pretty error messages. with
Free
color.
error messages? Pretty error messages.
Undo.
Just like more readable.
No, it's fine. We've got another slide.
Oh, you did. Okay.
Yeah. So,
There is a ticket which has some ideas on how this can be done. If somebody is interested in picking it up.
Yes.
But
well, I'm actually interested, but like we use a fork of a pretty library, and there needs to be a decision making what to do about that.
Well, that's the fork of the pretty library.
This also needs editor integration, so an Emacs hacker will be welcome.
Anyway, so this is something that I think is more than the work of a moment, but I'm definitely not going to do this, but I think it's David's work has shown that you can do it in quite a nice systematic way, which you probably tell us how to do it again if we want to.
There's videos from my talk last year.
There's videos, yes. So this will be a nice project and very separable from everything else. Yeah.
Yeah. Well, we're talking about error messages, so. Rust has this interesting concept that you have every error message has a number, and you can sort of like type Rust C explain, then the number, and it prints out what's actually happening, so explains the error with examples and stuff like that. That's really useful when you run into something that's rather obscure. Yes.
That requires a bit of resourcing, right? Not only to run around and add numbers to everything, but also then to write a lot of explanations. So again, I think my instinct is that we do that if some group of people were signed up to write the explanations.
But you can just start with this without writing the explanation. I don't know, Stack Overflow will get these explanations. And then you have the key that people can Google for.
Yes, maybe. Or
yeah, if we just had an error code for every error message, that would be easy.
And then you could. It's true that it would be much more grabbable for, wouldn't it? Yes.
Stack Overflow.
Yeah. Or instead of having a system to look up error messages, you just use Bing.
Vision.
Yes. Yes, right. Where do we go? David, yeah.
This is the thing I would like to see done, not a thing I would like to do. So, caveat.
Yeah.
But I would like to have GHCI give me header.
Yes.
Oh, yes.
Wow.
Yes.
Yeah.
Yes.
Because oftentimes you'll have like similar interfaces from various libraries, and it'd be nice to know like this one that I've got imported, what does it do?
Right. Or maybe in a browser, or just directly in
I would like to see at least a summary directly in my editing environment, which can be built easily around GHCI. But it would be nice if it then maybe linked to the like dump down a file clone URL that your editor could parse and then open up in a browser if you wanted to see that.
So do that with Google or that would be.
But Google doesn't know which particular from list you've got in the scope.
Yeah.
Well, one question or request to have GHC compile on Ubuntu on Windows?
Be my guest.
That's more of Ubuntu on Windows problem.
I'm ready. I don't have anything else to say. So I'm in your hands. We have one more back.
So this is a thing that came up in the aftermath of the foldable traversal thing. It might be nice, I don't know if there are other instances of this, but it might be nice if you could mark certain class instances as undesirable. So essentially, if GHC ever sees a constraint that has this form, just throw an error instead of resolving it, even though it could. Because, I as a client don't like that behavior.
You don't really have this?
We've got deprecated instances, we've got deprecated functions.
But I think that's more permanent. That's
Yeah.
you mark the class in that way. Okay.
Yeah, so the idea is like, if I'm writing some library and I'm importing, base, for example, and I don't want to be able to take the length of the tuple, to use the simplest case, I could just say, annotate in my code, don't ever let me use the foldable tuple instance.
Mechanism for enforcing local style, not.
Yeah, exactly.
I see, yes. Right, cool.
So we've talked a lot about all the features we want to add at GHC. So Ben Gamari is going to now open up a discussion about how we can actually help people to contribute all these features. So please welcome Ben Gamari.